So I want to talk just a little bit together about factoring and what it is and how we're going to think about it in our first run through the course material when we're thinking about everything kind of at a beginner's level. So what are the most basic things that we need to know about what factoring is and how it works? So let's just start with an example of what it would mean to factor a number. So I'm going to choose a number, let's say 36. If I just tell you to factor the number 36, what does that make you think of? Sort of where does your mind go? How do you think about what this question is actually asking you to do? What does it mean? Okay, so hidden inside the word factor is a notion that has to do with multiples. Okay. So factoring in some way is intimately related to the operation of multiplication. And in fact, these two things are, in a sense, opposite to one another. And what I mean by that is that in math, if I say I want to know what are the multiples of the number 36, well, multiples of 36 would be the results of multiplying 36 times some whole numbers here. Whole numbers. So, for example, if I fill that blank in with a 0, then 0 is a multiple. If I fill this blank in with a 1, 36 is a multiple of 36. If I fill this blank in with a 2, then 36 times 2 is a multiple of 36. If I fill it in with a 3, then 36 times 3 is a multiple of 36. And so on and so on. So my first question is, how many multiples of 36 are there? Infinitely many. We can keep going. We can have as many multiples of 36 as we want to. So this goes on forever. Which is nice in a way, and it means that we never run out of multiples of 36 if we don't want to run out of them. But it also makes it a hard problem because we can't actually list all the multiples of 36. Fortunately for us, we don't have to. Fortunately for us, if we're asking about factoring, we're not asking about getting bigger. We're instead asking about breaking apart and making smaller. And asking the reverse question, which is not what numbers can I get when I multiply 36 by something, but instead it's how do I make the number 36 by multiplying together a couple of smaller things. So if I ask to factor the number 36, what's one way of factoring the number 36? Yeah. So one way of factoring the number 36 is to write it as 36 times 1. Okay? Because 36 times 1 is equal to 36. What's another way? 6 times 6. That's another different way of factoring the number 36. And then there are others in between. We could do 18 times 2. We could do 9 times 4. And I think I'm missing one. Yes, I am missing one. Which one am I missing? 12 times 3. Absolutely. So there's another way. Am I missing any others? Not really. I mean, I could take any one of these and turn it around. 1 times 36, right? But that's not really different. It's really just sort of telling us the same pair of numbers because multiplication is commutative. I don't feel the need to list that as a separate way of factoring. And so we have now a bunch of ways, but how many different ways are there to factor 36? Looks like there's only 5. So unlike listing the multiples, where that list goes on forever, if I want to list the factors, I am not going to go on forever. In fact, it's a very deep fact of mathematics about the whole numbers, that there is only finitely many different ways to factor. And at some point, we end up repeating ourselves. Right? So 36 is an example of a number that we can only factor in 5 essentially different ways. What else do you notice, if anything, about the factors that are in this list? Let me make that question a little bit more coherent. So if we're going to think a little bit more deeply about factoring, I could, if I wanted to, list every number which is a factor of 36. and there would be not 5, but I could go through this chart that we made up here and kind of count each different number that I see once. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are the different factors of the number 36. So there's actually quite a few, but it's still, again, a finite number. 6, 9, 12, 18, and 36. Mathematicians also have this peculiarity that they like to be systematic about this. When we were sort of coming up with these factorizations, we were sort of guessing and checking, hunting around, just sort of doing our times tables in our heads backwards. That's how I think about what factoring is, right? Which is fine. But if we want to be really systematic about it, there's another tool that we can use to break the number 36 down into as small a pieces as possible. So let's think about that for a second. Smallest pieces. In this list of factors of 36, which of the numbers in this list have other factors of their own, can be broken down further, maybe is a way to say it. So we know 36 can be broken down further because it has a bunch of these other factors. So how about, I don't know, how about 12? Right, so 12 can be broken down further. 12 is on this list because 4 and 3 are on this list, right? 18 is on this list because 9 and 2 are on this list. So in a way, our list has some redundancies associated with it, right? We don't need to list 18, for example, if we are listing 2 and 9, because any number that has both 2 and 9 as a factor will also have 18 as a factor. Same thing with 3 and 4. If I list both 3 and 4 as factors, then I'm guaranteed to also have 12 as a factor. So what are the simplest pieces, the smallest pieces in this list? The ones that explain the existence of all the others. Those would be the pieces that don't break apart any further. 1 is 1, sort of. I mean, 1 is always going to be in the list. 1 is a factor of everything. It's like, what's that blood type, O negative or something, that everybody can take O negative blood, right? Because there's no antibodies, nobody has any antibodies against it, and so if you have that blood type, you can donate to anybody. 1 is like that. It's a universal donor. It's a factor of everything. Okay, so 1 is definitely something that can't be broken apart any further. What else? 3, sure. Because what factors does 3 have?
1.
Just 1 and 3, right? So no other pieces that are interesting. What else on this list has that property?
Should be
2. 2, the only factors of 2 are 2 and 1. But then 4 is on this list, and it can be broken into a pair of 2s. 6 is on this list, and you can break it apart into a 2 and a 3. 9 is on this list, and we can break it apart into a pair of 3s, and so on. So these 3 pieces that are the smallest, what kinds of numbers do we call those? Prime numbers, exactly. So these are the prime factors. And I'm not including 1 for a technical reason here. Prime factors of 36. Prime meaning that only themselves and 1 are factors. So those are the smallest building blocks of the number 36. We can build the number 36 just by multiplying together some 2s and some 3s. We don't have to have anything outside of those 2 sort of original prime factors to make the number 36. And if we want to be really systematic about it, the usual tool that gets used is called a factor tree. So I'm going to replace this sort of list of factors that we had up here with a quick factor tree determination for the number 36. So if I want to determine what are the prime factors of 36, what I might do is I might start by asking, well, let's take the smallest prime number that there is. What's the smallest prime number that there is? 2, because 1 is not prime for technical reasons, so 2. And ask, does 36 factor into 2 times something? Yeah, it does. 2 times 18. Okay. And so we'll begin our factor tree by breaking apart 36 into 2 and 18, and then focusing, in turn, on the number 18. Is 18 divisible by 2? Yes. It's 2 times 9. So now we've discovered another 2 as part of our factorization of 36. And then our attention turns to the number 9. Is 9 divisible by 2? Yeah, 9's not divisible by 2, but it is divisible by the next largest prime, which is 3. Right? 9 is a 3 times a 3. And now, at this point, none of the numbers that are at the ends of my tree branches here can be broken apart any further. Right? And so at this point, we're done with what's called the prime factorization of the number 36. It consists of all of the numbers that are at the ends of the branches of this tree. And so we could write 36 in its prime factorization as 2 times 2 times 3 times 3. Or if we wanted to be enterprising and save a little bit of ink, we could rewrite this using exponents. 2 to the power 2 times 3 to the power 2. And that's called the prime factorization of the number 36.